This question is about rates of reaction. Phosphonate ions react with hydroxide ions to produce hydrogen gas as shown. A student completed an experiment to determine the initial rate of this reaction. The students used a solution containing phosphonate ions and measured the volume of gas collected every 20 seconds at a constant temperature. Figure 1 shows a graph of the students' results. Use the graph in Figure 1 to determine the initial rate, which is the rate at time equals 0, for this experiment. State its units and show you're working on the graph. So the initial rate is the rate at time equals 0, and this is volume against time. So it's essentially a concentration time graph. And so rate is the gradient at a particular time. So at time equals 0. So what we need to do is draw a tangent. We need to line up our ruler with the curve at the very start. So you're just going to line your ruler up, and then you want to be able to draw a tangent to the curve at time equals 0. Then you want to measure the gradient of that tangent. So my dy, I'm going to actually go all the way up to the top here and create a triangle that includes all of this space. So if I were to draw this vertical line here, you would be able to see it. I'm actually going to use the axes as part of my triangle. Bigger is often better for these. So my dy is 200 and my dx is 30, going up in 2, so 34. So 200 divided by 34 on my calculator, which is 5.88. Now, for this particular gradient, the exam board accepted anything between 5 and 7 as your rate. So based on drawing an appropriate tangent to the curve at time equals 0. The units are going to be the units of the y-axis, centimetres cubed, divided by the units of the x-axis, so centimetres to seconds to the -1. Another student reacted different initial concentrations of phosphonate ions with an excess of hydroxide ions. The student measured the time taken to collect 15 centimetres cubed of hydrogen gas. Each experiment was carried out at the same temperature, and Table 1 shows the results. State the relationship between the initial concentration of phosphonate and the time. So let's pick some numbers that are easier for us to see. So we could see here that when this doubles, this quarters. We could also do that here when this doubles. I'm not picking the 0.35 because it's not a nice fraction. This one quarters. Now, we know that the number 4 is the same as the 2 squared. So we can say that H2PO2 minus squared is proportional to 1 over time. So 2 squared, the change in the concentrations, so 2 squared is 4, is proportional to 1 over 4, a quarter. Yeah? So that's our relationship. You might want to write that in a different way. When concentration is doubled, time is quartered. You could just write it like that if you aren't able to write it as a proportionality. That means that the order is 2, because we can see that relationship has got the squared in it. The order, remember, relates to the rate, which is 1 over time. And if we'd worked out the 1 over time values, then this would have multiplied by 4. So 2 squared is 4, order 2. Complete the diagram in Figure 2 to show how hydrogen could be collected. So the best way to do this would be with a gas syringe. So we need to draw a syringe. So remembering that a syringe is a jacketed piece of apparatus in that there's the syringe casing, and then the plunger sits inside that syringe casing, very tightly though, so that air isn't escaping. And that's kind of got our syringe end on it. So we have this is our conical flask. This is a syringe. It says the rate equation for a different reaction is rate equals K times L times M concentration squared. Deduce the overall effect on the rate when the concentration of both L and M are halved. So if L is halved, and it's to the power 1, and M is halved, and that is squared, if we type that on our calculator, we will get 1 over 8. So rate is times by 1 over 8, or rate falls by 8, or rate is divided by 8. The rate of reaction is 0.025 when the concentration of L is 0.0155. Calculate the concentration of M if the rate constant is 21.3. So let's just look back at our equation. It said rate equals K, rate constant, times L to the first order, power 1, times M squared. And it wants us to find M. So remember that M squared, if we divide both sides by rate by K and L, so then the concentration of M would be the square root of rate over K times L. So we can put the numbers in. So square root of 0.0250 divided by 21.3 times 0.0155. I want to put all of that into our calculator. So the square root of 0.025 over 21.3 times 0.0155. And we're square rooting that, and we're getting 0.275. And I'm going to give my answer to 3 significant figures because that's what the numbers were given to. Define the term overall order. Overall order is the sum of the indices or the powers in the rate equation. So for example, the equation we've just been using, the sum of the powers would have been 2 add 1 is 3. So the overall order would have been 3.